So our next speaker is Chamiel from Taboola. He will present his work close enough, but not more of the same, work on personalized diversity in recommender system. Thank you.
Right. Hi everybody, my name is Gil. I'm from Taboola. I'm quite sure you're familiar with Taboola, even though you might not know that we're looking at our recommendations. Taboola is a recommendation system which does primarily two main products. One is sponsored content marketplace, and the other one is more organic recommendations. The talk today talks more about the organic part recommendations. Also going to try and bring a more real-world sort of a problem and the results and how we approach it. So when you look at the recommendation system in a very, very high level, like I want to define a few properties of what is a good recommendation system. So it should probably recommend things that are related to your interests and that are diverse. So even if it's related to your interests, you don't want to see only the same thing again and again, even if it's really interesting for you. So how much can you like Roger Federer? And also, you don't want to see the same items, not more than one. So when it's the same item, it could be different articles, but talking about the same story. That could happen. We'll see a very relevant case where that could happen. So you don't want that. And also, you don't want to see repeatedly things that you saw already. So like you want to diversify the experience of the user over time as well. So what do you want to capture in order to be able to do that? So in general, the talk talks about how do we capture similarity in a sense between articles in a way that allows us to capture it in multiple levels of granularity. So we can diversify in multiple levels. What do I mean by that? So for instance, these two articles talk about the same story. It was Trump visiting North Korea. Exactly the same story coming from two different publishers. So one's Fox News, other one ABC News. If I show these two together to the user, it's really not useful. I want to show one because it's talking about exactly about the same case, same story. On the other hand, there is a more soft related article sort of a case, which is more interesting. For instance, you've got two articles talking about two different stories from the same competition, from Wimbledon, or two different angles of the same story. So Trump and Ukraine case, these are two from the same publisher, Huffington Post, and they are both talking about the same case, but from different angles. Okay, so it's not exactly the same story. You want to be able to capture that. And why do we need it? So we need it for all sorts of different cases. So for instance, for click-through rate prediction, if I know how to capture an article in a good way, then I'm able to, for instance, predict the click-through rate for that article very early on after it was published, even before I have any information about clicks on that article. Also, if I want to model content relatedness, so I want to show users articles which are similar to articles which they're looking at right now, or it could be over time, so looking at your profile and generating a profile which is meaningful. And also what the case we talked about a little bit when it comes to story deduplication. So we want to be able to capture this notion of similarity. I called it to model items as an infrastructure. So to have a good item representation, which is good for different cases. We'll see that some cases it's not so easy to capture everything. So just to give another intuition or like a motivation for why it's important, let's look at the correlation between the similarity score and the click-through rate. Okay, so this is, when you look at the y-axis, you'll see that the numbers are not between 0 and 1. It's not a probability to click. It's a calibrated version of it, which we find useful, much more useful than looking at the actual rate. And the similarity score, and we can see there is a clear correlation. So it doesn't mean that if I show users similar articles, they're always going to click. It doesn't explain it fully, but there is a correlation. And also there is a correlation across like multiple similarity scores. So I want to be able to be not only good by saying these two are really similar, like in this area, I want to be able to do a good job over the entire spectrum. So let's look at how we can model this. So first thing you can do, which is relatively easy, and it doesn't require data at all, is to take a pre-trained model. like a pre-trained, so we like to use neural networks in Taboola. So take a pre-trained model that was trained on a different problem. So it wasn't trained on to capture similarity between articles, definitely not articles of Taboola because it doesn't know about them at all. But it was trained to do a good job on language modeling. Usually it's the problem of completing a word in a sentence. That was those things are, or completing a sentence, or completing the words at the end of a sentence. So you can take LSTM is an RNN, like a sequential model, a bag of words, a simpler model, and BERT, which is made probably the most amount of noise in the last year or so, is a very interesting model. Are you familiar with BERT? And familiar with it? Yeah, I'm sure most of you do. It's based on this concept of transformers, and which is really cool. And all these models, even if you're not familiar with them, don't worry about it, because just look at them as a black box of being able to take an article and generate an embedding out of it. So take the words in the article. Usually we take the title and the body of the article, maybe not all of it, and then generate an embedding. And then you can just do a cosine similarity or something like that to get the similarity between them. And this is really useful. Because it's generic and it's you don't need anything for it. You can download those models from the internet. BERT is available in many languages, and it's very, very nice. So we'll see that because it wasn't trained on similarity, it doesn't perform as well as what you can do when you do have data. And even when you start looking at those simple models, you will start asking yourself, how do they perform? Now, the one thing you can do is to try and chuck all of those into your production system and try and A/B test everything. So that's difficult. One, because think about it, that there is two problems here. One is to capture the essence of the article, and then there will be modeling coming after that. For instance, to find the click-through rate of that article. Now, if it doesn't work, how do you know which problem, like where were you lacking? So that's difficult. And also, it's also scalable. You want to try many different things. You want to have some offline metrics. And so you want to start looking at the models, and the first thing you want to do is to start by looking at them whether they make sense. So you start sampling them, and looking, spending some time, trying to understand the weak points of the models, where they succeed and where not, and stuff like that. And another thing, when you start looking at the scores, you'll find out that they could give very, very different distribution of scores. So you can see that BERT, for instance, is giving much higher similarity values across the board. So when you compare them, it's important because when you compare them and you just compare the scores, it's sort of apples to oranges. So we like to look at the percentiles of the scores and not so much at the score value itself, stuff like that. So these are kind of an evaluation procedures, let's call them, not even metrics, that give you a bit of intuition whether you're on the right track. Also, you can look at user data, and you can assume that if you assume that the users have some sort of consistency in their interests, when you plot the articles that they look at, and you look at the similarity between them, then you will see, or look at the embeddings at least, you will see a good level of separation. So we have two users. One likes politics for some reason. The other one really hates crime, but he look at it a lot. And you can see two models, LSTM and bag of words, where the LSTM model just intuitively, when you look at it, when you just plot it in TensorBoard or whatever, if you're using TensorFlow, then you can see that there is a better separation. It's already giving you some sort of an intuition whether your model is capturing something meaningful. And again, this is based on the assumption that users have some sort of consistent interests, which is not far-fetched. But it's not a metric. So we'll get to the metric soon, because right now we don't even know what exactly we're looking for. So, and the next thing, so I'm gonna present the next modeling idea, and then we're gonna tie up a lot to the way we measure things, and you'll see in a second what I mean. So the other thing you can do is to take a pre-trained model and then fine-tune it or retrain it again for your problem. What do I mean? You can there is a technique called Samus networks, where you take the same model and you look at it twice. Once with the item 1, once with item 2. And then you do the same trick with embedding and some distance function between them, but then you chuck in another loss at the end, and the loss looking at your problem. So you need to have some labels that will tell you whether things are similar or not. And then you can start with the BERT model, which is trained on just language models, and then you're going to fine-tune it to your problem. And obviously, you're going to expect to see much better results on your problem. So, but we're left with what is the loss, and how do we get the labels? So I'm assuming that I know what is similar and what is not, which is not so easy to get. So it's not that you can ask users that, like if users click on this or that, it doesn't tell you that. So it's not so trivial to get the labels. So let's spend a second thinking of what exactly we're looking for here. So when we're talking about the labels, what even those labels going to be? So I'm looking at now at 4 levels of 4 classes. One is same story. So exactly the same story. Again, Trump and North Korea, two publishers talking about the same story. Looking at related stories, so that are not talking about the same, exactly the same story, but are related. The same topic, so they're related by a little bit weaker, and not related at all. So they're talking about different topics, and I want to know that. So for now, until we come back to this problem, let's look at those 3, because it simplifies things a lot. So where do I get this data? I want to be able to get this data. So one thing you can do is get some manual annotation. So you can budget a little bit of money for crowdsourcing. Taboola has got its own editor, so we can ask the editors to tag some data for us. So we're going to present them with pairs of articles. And we're going to ask them, are they related, are the same, related, same topic, or different? They're going to tell us that, which is good. That it gives you good data. It's probably going to be quite accurate. Again, it really depends on the crowdsource like quality, and some crowdsource vendors don't work in every language, so there's a limitation there. But there is a big limitation is on scalability, because think about it like this. First of all, topics keep on changing in the world. So you can do a crowdsourcing batch, and then after a month you probably want to do it again, and that's going to be a little bit expensive, and also not so scalable. Same thing with languages I mentioned just now. So this is good for if you want to run a test set. So what we're looking for is data that will allow us to retrain our model for those problems. So we need a lot of data for that. I mean, tens of thousands of maybe 100,000 pairs, which is going to be difficult to get from crowdsourcing or doing it manually. But it's a good start. At least it will give you a test set. If you get a test set of 10,000 items, you can at least say which similarity method is better or not. Or you can try and utilize editorial decisions, and let's see what I mean by that. So but the premise is that the truth is out there, and it's out there in this form. So we partner with the publishers, so we are allowed to look at their sites, at their data. And many publishers, they have their own related coverage widgets. So the editors, when they publish an article, they manually tag those widgets. Maybe they have a search engine that helps them with that, but they're looking at it manually, which is that's the important part. So you can look at those related coverage, like this is I think from the Huffington Post. I'm not sure. There's many other publishers do that, and that gives you at least the class of related stories. Usually, it's going to be very related stories. Also, the publishers again they take their own data, and when they publish an article, they usually tell what is the topic of that article. Sometimes it's in the level of topic, like Golden State Warriors in this case. It's an NBA team. And or sometimes it's just a category, but it's something meaningful which can tell you some level of relatedness if you're comparing two articles which share the same topic. And then you can choose randomly for the rest. Obviously, it's those that don't match the first two. So something from different topics. So it's a pretty scalable way of getting our labels. So we found that that was really something that gave us a really big boost in our modeling. So now I can chuck that into the labels. So I have 3 labels: a related story, a same topic, and unrelated. So I'm just going to look at my time. I'm good. And I'm going to do the modeling based on those. So I'm going to start with a pre-trained model, BERT or bag of words or whatever. We'll see some results in a second. And then I'm going to take that and I'm going to retrain it or fine-tune it to be able to say something intelligent about those 3 classes. related stories, same topic, and unrelated. And now the question is, what is how I'm going to model it exactly? So what's going to be the loss? How am I going to relate the distances that I get here with those labels? So one thing you can do is to treat it as a multi-class problem and have a cross entropy loss. And then I predict the class, each class separately, and take the highest, which is fine. And you'll see that in a second that it's giving a significant boost, probably the largest boost. As soon as you start using this data, it's pretty cool, and it's giving a very, very nice result. However, there's something a bit unintuitive there. This is a little bit like a star rating thing, right? There is a relation between the labels, meaning it's ordinal. So the related story is more close to same topic and then only to unrelated. So it's not, there is an order here, which in the order is important. We can utilize that. So you can utilize it in two ways. You can decide that you're looking at it as a regression problem. And you're just going to, so you say this is 1, this is 2, this is 3, and I'm going to predict 1, 2, or 3. Predict the number and see whether it's closest to 1, 2, or 3, and that's going to be my label. Which, by the way, it sounds a bit odd, but works quite fine. And or you can use a loss, which is a thing a little bit less popular. It's called ordinal regression. Have you heard of ordinal regression? So it's not so popular. Which is trying to tackle this problem. So it's something between regression and classification. And the idea is that we do treat think about it like this. The problem is that we don't know when something stops being related and just becomes same topic. Okay, it's kind of fuzzy, right? So we want to be able to find those thresholds where they become jump from one class to another. That's what ordinal regression is trying to do. So it's trying to predict every class like a logistic regression problem, like trying to predict it with again as a class, as a classification problem, but also it to try at the same time to find the thresholds when things jump from one class to another. So it's very sensitive in that sense. There is a pretty cool blog post which kind of visualizes that. I put the link here if you want to look at it later. It's kind of nice. And okay, now I realize that showing stuff when I move with the marker is not so convenient. And so what it does is that it takes, again, it will going to try to predict what is the probability to be in the first class, second class, and so on. But then it tries to find those cut points. Those cut points are in the black, and it's got a little bit of details of how to implement this, which is not so trivial. But nonetheless, it's very nice. Another advantage of this is that you get the cut points themselves. Sometimes those are interesting. For instance, if you want to create a widget which only gives you related stories and never gives you something else, you want to be able to say what is the threshold. So you can do a regression and run some analysis after that to see what would be the thresholds like empirically, but this gives you that out of the box, which is really nice. These are just the intercepts of the model. So it's a very nice technique and very useful. So let's look at some results. So here I'm going to present three things. One is whether the models were able to be able to predict something is related story or not. So related story or the rest, and stuff that are unrelated or the rest, also interesting sometimes. And whether it was able to find the fine-tuning between related story and same topic. So the first and second. So first we're comparing a bunch of pre-trained models. Again, the models are discussed in the beginning. LSTM, Bag of Words, and BERT. So quite rightly so, BERT is a big hype. It also works really well for this. This is without any retraining. So this is just taking the models, the language models, and chucking them in, taking the embeddings, and seeing whether they give you a good separation between the classes. Again, at the end, forget about regression. When it comes to testing the classes are just classes. You just want to see whether you match them or not. So I'm looking at the area under the curve for those, and it gets quite nice results, especially for whether to say, well, actually, this is a very nice result in my mind. The BERT never knew that I was looking at related stories, so I think it's quite nice that you get that out of the box just by downloading a model from the internet. Also, we want to see how what boost do I get by retraining. So here I'm looking at looking at model, the BERT, which is the Pretrained model, the model that won the previous slide. And then I'm doing retraining with Samus networks, one classification and one on regression. And you can see that already I get a really big jump when I'm looking at my problem as when I retrain it, even if I look at it as classification problem. But there is another boost when you're thinking about the order of things and the classes actually, the relation between them actually makes sense and they mean something. And I do get another pretty significant boost in precision after that. All right, so now I left the same story problem aside a bit, and I want to get back to it. So let me give you a concrete case. So Taboola's got a relatively new product called the Taboola News, where we show, Taboola we usually see Taboola in publisher sites. So this one is actually shown on mobile phones. So we integrate with all sorts of mobile phones, and then we show a newsfeed, which comes from our publishers. So, and in that newsfeed, sometimes our partners like to have a top news section. So show me the news of the hour. What are the news of the hour? Now, if you're going to look at Huffington Post, and New York Daily News, and NBC, and all these guys, and there's a big news piece, they're all going to say the same thing. Okay, so this is, it's actually quite an old article. I don't know if you remember. There's something called a correspondence dinner in the White House. And Trump was supposed to show up, and he didn't, and it made a big splash, and Michelle Wolf went up and spoke about it, and everybody talked about it. So these are two, so if you don't do anything, your top news section is going to look like all the items from all publishers talking about the same thing, which is boring for the user, it's not interesting. In this case, you can clearly see that it's the same story. It also looks like the cameraman was either the same one or were sitting much close to each other. So it's really the same story. It's no doubt about that. Now, to be able to dodge that, this is a more delicate task. Okay, it's going to be either the same story or not, and also we treat it as a bug if we do have the same story in our widget. We don't like it at all, and it's not so easy to find like those I call it here organic annotations, like. Editors don't just put the same story again and again like they do with the related coverage widgets. So we don't have that data, so we probably need to do some manual annotation. And also, again, we like to look at it as a more special task. And also, you can use, since it's a delicate task, you can use a slightly more powerful tool, and it's called triplet loss. So there is a variation of Samus networks where you don't look at Siamese twins, but you look at the triplets. What do I mean by that? So you take an anchor article, and then you bring a similar article to it, so something that's known to be similar, and a different article to it. So in our case, it will be a same story or not same story. And then you do the same thing, right? You take a pre-trained model and you fine-tune it, but the loss is a bit different. So the loss now, okay, so you'll get the distance of the similar ones and the distance of the different ones. And what you want to do is to be able to like maximize the distance between them. So you want to separate them. Also, one of the special things about triplet loss is that I've never seen anyone describe it without doing this, and it's probably more descriptive than any word. So yeah, so you want to do this. So you take you want to maximize the distance between them, and that really helps with separating the good and the bad, the same story and not. It's a little bit more difficult to make this into like an infrastructure like that does that for many different problems, like we like to do before. But it's useful here, and we'll see why in a second. Also, another reason is that, again, for the do problem, we didn't have very scalable data, so we needed to use our editors to be able to tag those items manually. And so we got a few, I think maybe 10 or 15,000. Sorry? I think not, but I can look at it later. It's a bit going to be difficult to debug this when I'm talking. It could be, but I think not. Then we did pre-train this for this particular problem and not for all the other problems. And let's look at a bit of a result. So first, again, to get a benchmark and to get a bit of an idea of what you get without all this headache of triplet loss and preparing the data and training the models and bothering the editors with this. Then we took some pre-trained models, and they do okay. So it's interesting that LSTM and Bear don't really differ between each other. And then this is the result for triplet loss. So you get a nice uplift. Again, we didn't have huge amount of data here, and you need triplets as well, which is not so convenient. But we did get a significant boost. We did try to take the model that we trained on the related story problem and see whether they do well here. And it's interesting that they actually perform worse than without doing the retraining. So we train it for, it makes sense, right? We train it for a specific problem, or another problem, it does less of a good job. That kind of makes sense. So to summarize, we like to look at the item modeling as an infrastructure when we can find various levels of similarities between things in order to be able to chuck those into different algorithms and use them for different problems. In some cases, like the dedupe problem, you're going to have to do a more concrete job, one modeling work to tackle that problem in particular. Also, we found that evaluation is critical. To be honest, until we decided that we're going to, which is a crude decision, right? To say you're going to, this is related, this is the same topic, this is not. We were sort of in the fuzzy places where we look at it in like with our own eyes, trying to say which one is better. And then how do you interpret when people don't agree? And people don't agree, then once we're able to find a good data set that gives us a KPI which is concrete, it really got us moving. And again, the main improvements we got were from fine-tuning the models using explicit data, and finding a good loss function, and obviously finding a good language model to begin with. One thing we didn't do is take like a BERT model, take our own data, retrain it on the language model problem, and then retrain it again on the similarity problem. So good thing there's more things to do. Also, we didn't discuss multilingual modeling. So again, another good thing about BERT is it comes, there is a multilingual version of it, and we do work in many languages, so it's very relevant. There's another technique I didn't cover called universal sentence encoding, which is also multilingual models, and it's a bit newer. So right in NLP, every 3 months there is a big the next big thing. Everybody forgets about the last one. Like LSTM now is considered to be obsolete, right? Also, you can work with multiple modalities. So sometimes you want to be able to capture similarities between the creatives themselves, like the images. So you can do the same trick. You can start with Inception or whatever computer vision model that you like, and then retrain it. Probably a little bit more difficult. Usually those models are a bit bigger, but it's definitely possible. And also, when you implement this and put it in production, there's multiple implementation details, considering what happens when you retrain your model again. The embeddings completely change, so you need to have some sort of versioning and stuff like that. If you want to hear more, I'm happy to discuss it offline. And I think that's it.
Thank you very much, Gil. So we have a few questions, so let's start by Klaus.
Yeah, you've talked about the similarity of a couple of items, like 2 items. How do you deal with, the many articles? Do you calculate the similarity score of each combination?
We look at there's ways to diversify a widget. When you look at pairwise distances, so you start with 1, you compare to the first one, and then you compare to the pair, and so on. So but we never trained any models which are looking at more than 2 ones, because I think it's capturing the right phenomena. Did I answer the question?
Yeah. Thank you for the great talk. My question is about your earlier slides about capturing data and data use in the context of surveillance capitalism. There is today a growing awareness of this political human crisis that companies capture human data, model it, make prediction products such as you do, and then sell those products in order to change what people do more and more successfully. So my question is, what have you have you considered in what is the ethical rights of Taboola and other similar companies to capture data of human behavior to begin with and use it, in the context that there is no regulation about this yet? Have you considered these issues?
Yeah, so definitely. So can you hear me? So first of all, when you look at the organic data, then we never generate any articles. So we only present articles which exist on publishers, and usually in Taboola News, for instance, we use premium publishers. So it's not going to be this fishy publisher which might have fake news. Fake news is the main problem here. Also, we have a team of we call them content policy, which look at every article that is coming from outside. So if someone wants to start a campaign in Taboola, to be able to authorize it. So I think that those two things, only recommending stuff which are coming from premium publishers and manually monitoring it, is answering for that, but very, very, very sensitive to it, absolutely. So you're looking like I didn't answer the right question. Change the behavior. Yeah. Right. So our metrics, our KPIs at the end are user engagement metrics.
Yeah. Maybe we can continue this discussion afterwards. We have one question.
Yeah, I have a shorter question. In your very first example, you showed the same story from different sources. One was Fox News, one was ABC News, but but the user can react very differently to the same story. It's a more favorable source. So how does that factor in your KPI, in your goal here?
Yeah, absolutely. So the goal will be to find. So if I know that there are two articles coming from two publishers, and I know that you like Fox News, I want to show you the Fox News one, and maybe if I like ABC, I will want to show me the ABC one. But I don't want to show them both of them together, right? So there is another problem which I didn't discuss today about the personalization part. How do you match it to user interests?
Okay, so you know it's the same story, but you choose the one that is
exactly.
One more question. Very popular.
Yes, I would like to ask about you present two approaches for solving the semi-supervised learning problem. I mean, you have 3 categories, and you present one way to do it is to apply a classification loss, and the other is ordinal regression loss. Can you describe which one perform better? And yeah.
So I think I did present some results there about that the regression one did better than classification one. Mm-hmm. So we want to go back to the here. Mm-hmm. Yeah, so one with the regression, one with classification, mm-hmm. And okay. Got better performance there.
Thank you.
Cool.
Thank you very much. So we have a lunch break and then continue our talks.